J11 and I will be doing a rocket flying tea bag experiment. Now, for this experiment, a quick warning, we will be using fire and sharp objects. So please do this with an adult supervision. Now, for this tea bag, I will be using this Japanese green tea bag. So, let's get on to the experiment. First, what we're needing is a tea bag, a lighter, scissors, and also a place to keep your tea. Now, you might see all of this dust and wonder, what is that? Well, that's coming from inside of the tea bag. And you might wonder, well, why is it there anyways? Well, that is because not every experiment will work the first time. Now, I have been trying this dozens of times and it turned out to be a fail. But don't worry, that's the part of science that we will have to go through in order for our experiment to be success. Now, let's get on to the experiment. So, first things first, we're gonna open this and just cut it open and remove the insides of the tea, sides of the tea bag, just like that. And we're gonna cut it in half so we can do it twice in this video. Now, I'm gonna move that aside, keep this aside too. And what we're gonna do is we're gonna roll this thing up, just like that, make it a circular shape, let it stand, just like that. Now we're gonna heat it up, and let's pray it works. Gonna slide it up, and let's see, does it work? Will it work this time? Oh, unfortunately, it didn't work this time, but don't worry, we have one more tea bag. Now, let's just spin it again, do back all of the process, maybe make it, unfortunately, it broke, but don't worry, I will just try it again. Now, what we're gonna do is just try to recreate the circular shape. Okay. And we're gonna burn it just like that. Ooh, and it flew. Okay, so what this experiment is about is the heat from the lighter, from the fire, makes the air on the tea bag less dense and creates a current for the ash to make it lift up and fly to the air. As you saw just now, I failed once, but before this I failed many times. But don't worry, that's part of the process. At the end of the day, it became successful. Anyways, that is all for today. Thank you for watching. Bye!
Hi, I'm Shanice from J1I, and today I'll be talking about minerals and crystals. Why are they important? Firstly, we use them in everyday life, which is included in glass, lead in pencil, toothpaste, and even white paint. How many minerals are there in the world? There are over 4,200 different minerals, but only 100 are common. Ones that are rare include gold and silver. A mineral must have a crystalline structure and a definite chemical composition. And the mineral must be formed by geological processes, must be inorganic and solid. Minerals are made of molecules, and a crystalline structure is a repeated pattern of these molecules. The crystalline structure explains the geometric shapes that crystals take on when they grow under favorable conditions. Crystals will keep growing and growing forever as long as they have the chemical elements and the environmental conditions necessary. Crystals are not living nor are made by living things. Therefore, shells are not a type of mineral, but they are made up of solid materials similar to some inorganic materials. Minerals may be dissolved in liquids, but they themselves are not a liquid. Many minerals crystallize from liquids, principally from magma or lava, hot waters, or oceans. Others are formed when rocks are reburied below the Earth's surface and exposed to high pressure and temperature. The Earth's surface is made out of plates that move. Together with erosion, plate tectonics concentrate some of these elements in bodies of rocks that can be mined. Crystals. Minerals are made out of regularly arranged atoms and grow as distinct objects called crystals. Crystals are made out of only one type of mineral. A crystal's atoms, ions, or molecules are arranged in an orderly, repeating pattern. Crystals can have different shapes depending on how the groups of atoms are arranged. Most come from a liquid evaporating or magma cooling. Minerals in a liquid precipitate out as the liquid evaporates. As more minerals precipitate out, the crystal grows in size. This is the end of my presentation. Thanks for listening.
Hi, I'm Imogen Chow from J2E. Today I'm going to demonstrate the electrolysis of water by using two pencils. So we need to prepare two pencils, 9-volt battery, connecting wire, a glass of water, and some salt. So let's start. First we put salt into the water. As we know, water is a bad conductor, so we put salt to increase the conductivity of the water. Next, we connect the battery with the connecting wire. Then we put the pencils into the water. And then we connect it with the connecting wires. You can see the bubbles have started coming out. The bubbles on the brown pencil is oxygen gas, while the bubbles on the green pencil is hydrogen gas. What is electrolysis of water? Electrolysis of water produces hydrogen and oxygen gases. The decomposition of water into the hydrogen and oxygen gas due to an electric current being passed through the water. So that's all for the experiment. Thank you.
Hello teacher, my name is Nicholas Tshung from J3D or Junior 3I. So my science project, I will be projecting this. This is a 4-channel hydraulic arm. It looks fake, I know. So I'm sorry I don't have a tripod or anything, so I only have one hand. So I only can use one hand to do it, with my other hand controlling it. So I'll demonstrate how this works. This one, the first one, will be controlling this, the movement. And see, it moves. So, okay. Next one, it's this one, you see? It goes up, it opens up, and it closes up, and it opens up. This one, the third one, will be this thing raising. Looks like Spider-Man, eh? So, yep, that's how it goes. The next one, well, this one, it's slower, slowing down, so know how to do this. Yep. Then open this up, we'll be grabbing things, bring it to here, close it. Obviously it's very weak, so don't expect much for it. So I'm going to somewhat demonstrate. This is Pascal's law. Pascal's law is a law of hydrostatic. It points out that when any point in an incompressible static fluid is subjected to an external force to generate a pressure increase, the pressure increase will be transmitted to all points of the static fluid in a short time. According to Pascal's law, if there are two large and small pistons in a fluid system, the pressure on the two systems must be equal, and the pressure is equal to the acting pressure divided by the area under force. And a small thrust is applied on the piston, and a large thrust will be generated on the large piston through the pressure transmission in the fluid. The hydraulic manipulator controls the sliding of the number 2 syringe by pushing and pulling number 1 syringe, and then controls the opening and closing of the grab through a set of mechanical structures. The structure is ingenious, the movement is stable, the modeling design has a mechanical sense. Okay, so if you're wondering what is which one is the number 2 syringe and number 1 syringe, this is number 2. This is number 1. Okay, this one controls this. You're gonna see the lines. So let's do this. Let me show you one more time. It turns. Well then. Oh, close, open. It's very weak, so I don't think I can grab that much. Probably enough to grab a piece of paper with holes. That is the end of my presentation. I am wearing a school uniform. Sorry about the pants, I don't have it. Okay, this is the end of my presentation.
Hello, I'm Rachel Dosini, number 37 from J3E. Have you ever wondered what would happen if you poke a bag of water with a pencil like this? Will it leak or nothing happens? So today I'm going to do a leaf-proof bag experiment. The materials needed for this experiment are water, a Ziploc bag or storage bag, and pencils. The procedure. Firstly, start by sharpening the pencils. Make sure the tips are sharpened to a point. Secondly, fill the Ziploc bag or storage bag with 1/2 of water. After that, make sure it is sealed tightly. Thirdly, quickly stab a sharpened pencil to the bag of water and see what happens. Lastly, try stabbing multiple pencils to the bag and see what happens too. The observations for both step 3 and step 4 are the same, which is no water is leaked out. Why is this so? The magic of this experiment lies in polymers. Polymers are long chains of molecules that make up so many items we use in our everyday lives, specifically plastic items. Ziploc bags like the one used in my experiment, plastic grocery bags, plastic water bottles, and plastic food packaging are all made of polymers. Think of polymers as long chains of beads. When you stab a pencil through the bag, the polymers move apart. This is the same as if you stuck a pencil between 2 chains of beads. Because polymers are flexible, when you stab a pencil through the bag, the polymers push back towards the pencil and form a temporary seal. This prevents the water from leaking out of the holes. Thanks for watching.
my name is Tshung and I am going to talk about the effects of music on plants. As we all know, plants need several things such as water, sunlight, air, and nutrients to grow and flourish. But have you heard of using music to help plants grow better? I've decided to carry out an experiment to investigate the effects of music towards the growth of plants. So I'm using mint as the plant for my experiment. I have 6 of them. 2 will be exposed to classical music, 2 will be exposed to noisy rock music, and the remaining 2 will not be exposed to any music at all. These are the apparatus that I'll be using as well for this experiment. So the manipulated variable for this experiment will be the type of music exposed to the plant. The responding variable will be the growth of the plant, which I'll measure using the height of the plant and the number of leaves. All of these plants will be exposed to the same amount of sunlight, given the same amount of water and air. They're also given the same care, where I'll change the water in the vessels every day for each plant. Every day, each plant is put outdoors, exposed to direct sunlight and the music that they are assigned to be exposed to. This is carried out between 12 p.m. to 2 p.m. To avoid the plants from accidentally hearing the other plant's music, I've made a very crude sound barrier for each of them by using cardboard and some towels for sound insulation. For outside of these 2 hours, the plants are placed together in the same spot of the house. The experiment is carried out for 15 days, and I'll record the data every 3 days. After 15 days of carrying out this experiment, this is what I found. In terms of height, the plants exposed to classical music grew the tallest, whereas the plants exposed to noisy rock music was lowest in height growth. But when it comes to the number of leaves, the plants exposed to rock music registered the highest number of leaves, whereas the plants exposed to classical music grew the least amount of leaves. It seems to me that classical music promotes apical dominance in plants, whereas rock music does the exact opposite. It promotes the growth of lateral buds of the plants. So what is the science behind this phenomenon? Now, the main factor isn't actually the type or genre of music played, because plants can't perceive that, but it's something to do with the frequency of the sound. According to the internet, the vibrations produced from the sound source stimulate cytoplasmic streaming, which helps in the transportation of nutrients in the plant. In addition to that, some sounds can make the stomata on plants stay open longer, which means they can take in more air and grow faster. Studies on music and plants haven't been carried out extensively all over the world, hence there are varying results produced from different experiments. But hopefully more studies about this will be carried out in the future so that music can potentially be used in commercial growth of plants in a more sustainable way.
Why do we feel happy when we are doing something we like? What is happening in our body when we feel happy? Hi guys, I'm Isa.
Hello, I'm Lokare.
I'm Harry and we are from Senior 2I. So why do we feel happy? This is because our body actually secretes 4 types of hormone to make us happy. So the first one is serotonin and the second one is oxytocin. It is often known as the love hormone, and the third one is endorphins. It is our body's natural pain reliever. And lastly is our topic for today, dopamine. It is released during pleasurable situations. Healthy levels of dopamine stimulates us to search for these kinds of pleasurable activities, whereas low levels may lead to unfavorable physical and psychological impacts. So dopamine, in other words, is making us addicted to something that makes us happy.
Oh, so how does dopamine work in our body?
So, dopamine is a neurotransmitter made in the brain and acts as a chemical messenger between neurons. It is released when your brain is expecting a reward, known as the brain reward system. This is a system which causes the feelings of pleasure when your brain is turned on by something we enjoy, for example, eating good food.
Okay, so does dopamine has its sets of drawbacks?
Yes, having too much dopamine in our body is linked to being more aggressive, competitive and having poor impulse control, which will then lead to conditions such as binge eating, addiction, and gambling. Besides that, there will also be an increased tolerance towards certain behaviors such as taking drugs or even playing games.
Oh, I see. So how do we encounter these problems?
The way to prevent ourselves from being addicted is by dopamine detoxification. During a dopamine detox, a person avoids any kind of pleasure triggers for a set period of time. This is also known as dopamine fast. However, it is not possible for a true dopamine detox, whereby a person successfully stops all dopamine activities in the brain. This is because the human body naturally produces dopamine even when it is not exposed to certain stimuli. In dopamine fast, by not drinking anything apart from water, not using the internet, your phone, your computer or TV, not listening to music or radio, not having sex, and so on. Instead, we can read, meditate, and go for some walks.
So to conclude, the secretion of dopamine makes us happy, but over-secretion of dopamine may lead to unfavorable situation, and we need to fast on dopamine to avoid it from happening. Moral value of this project is, although the pleasurable feeling is quite attractive, that we should learn how to control ourselves and know the time to say enough is enough. Thank you.
Hello everyone! Before we get started, let me show you a video that I've watched recently. Okay, so when I saw this video, my initial thought was that, does this guy know that it's really dangerous to do this because the coconut tree could bounce back and he would be thrown off the tree? But then I caught myself. Hold on, if the guy doesn't know that this would happen to him, how would I know? Most importantly, is my prediction true or even logical? To investigate this, let's introduce our topic today, cutting a coconut tree. So I was wondering, why would I think that it would bounce back? Obviously, not everything bounces back when cut. For instance, you don't expect your veggies to rebound when you slice them on your cutting board, do you? But look at what happens to a rubber band when I cut through it. So, what do you think? Would the coconut tree react like a vegetable or a rubber band? Let's find out. Okay, apparently it did bounce back. Now let's answer a question. How did I know that? In this video, this guy is exerting a force on the coconut tree to cut through the trunk. In fact, we have a name for that force. It's called shear stress. And this force causes the coconut tree to deform by bending. When the top of the tree is fully separated from the remaining part, the cutting force is no longer acting on the tree. So the tree, like any good old rubber band, snaps back to its original position. Wait a minute, why would the tough tree trunk behave like a rubber band? Apparently, both wood and rubber bands are made of polymers, long-chain molecules made up of simple repeating units. In this case, the tensile strength of the trunk comes mainly from cellulose, a natural polymer, while rubber bands are made up of polyisoprene. And polymers happen to have a property known as viscoelasticity. As an example, when something is placed on a wooden plank and removed immediately, the plank returns to its original shape. When a load is placed for some time, then removed, the wooden plank takes some time to regain its original shape. When something heavy is placed on it for too long, the plank cannot return to its original shape. In other words, whether or not the plank can return to its original shape depends on how long the load was applied. In this case, when the cutting force was removed, the viscoelastic property of the tree trunk allowed it to return to its original shape. Hence, the man was thrown off the tree. But now, what if I told you that you can minimize that rebound? In this example, force was exerted on both sides of the rubber band when it was cut to minimize the deformation. Thus, there is less rebound. But I'm not trying to suggest that someone else should be cutting from the other side. In my opinion, the best way to cut a coconut tree is at its base, at the opposite side of where the tree leans towards, so the tree does not fall in your direction when you cut it. Or don't even bother cutting them at all. A research estimates that a coconut tree can sequester around 22 kilograms of carbon dioxide per year, which is about the amount that you exhale in 22 days. So save your energy, save your life, and save the environment. But that's it for this video, and I hope you enjoyed.
Hi everyone! Today, I would like to talk about my 55th anniversary online exhibition project. The first thing we're gonna do is pour oil into a small cup. After pouring your oil, you can start adding some vinegar. After that, we can start to add some food coloring. Now ready a half cup of water and add a small amount of baking soda. Now the last thing we're gonna do is to mix both substances into each other. Now for the explanation. Oil and vinegar do not mix. When you drop vinegar solution into the bottle with the oil, the vinegar sinks to the bottom and the oil floats to the top. Vinegar is more dense than the oil, thus resulting in oil floating to the surface. As the vinegar solution falls through the oil to the bottom of the bottle, it reacts with the baking soda to make carbon dioxide gas. These bottles attach themselves to the colored vinegar and cause them to float to the surface. When the bubble pops, the color sinks back to the bottom of the bottle.
Thank you, Tsin.
For your 56 years of dedication, education, and commitment.
Happy 56th anniversary.
生日快乐！
祝崇正永远长青
，10年树木，
百年树人，谢谢。
Hi, I'm Mr. Pong. Happy 55th anniversary to Sabah崇正Secondary School.
Selamat ulang tahun ke-56 kepada Sabah崇正Secondary School.
Selamat menyambut hari ulang tahun ke-56.
沙巴崇正中学56周年快乐！
崇正56周年快乐！
沙巴崇正中学56周年快乐！
Happy birthday, Tshung.
Happy 56th anniversary to STTSS.
Hello everyone. I wish Sabah崇正Secondary School a warm 56th birthday. I am grateful and proud to see that this school has risen in the past to become one of the top schools in the country with 2,000 plus students. Thanks and congrats to all the BOG, the admin staff, and all my fellow colleagues that your efforts, your hard work and sacrifices have turned the school into a success story, one of the best in the country. Let us not be satisfied and continue to work harder and continue to make the school better in the next 100 years. Cheers!
大家好，我是张少伦，2000年毕业，在沙巴亚比工作。56载风靡，母校造就精英无数。56年沧桑，母校培育桃李满园。难忘你崇正，是你给我知识的蓓蕾，是你呼吁我前进的动力，是你孕育了代代莘莘学子。祝福你崇正，祝福永驻辉煌，谢谢。
我们高山校在此祝福沙巴崇正中学56周年生日快乐！
我非得理直气壮，不比谁都要倔强，颠覆世界眼光，义无反顾的闯，彩色天空是我唯一的方向。